In this session, we're going to look at strings. So remember that strings are one of the four main types of aggregate data, and a string is simply an array that's specialized, and it's specialized to only hold characters. We could use strings for all kinds of different things. One of the most common is to be able to say things to our users. So we would present on the screen strings of characters that represent information we need the user of that program to have. Another very common application of strings is in text files or Word documents, things that we want to write and express our ideas in words. And then an interesting one is in cryptography, so being able to code things or decode things based on character sets. So we've already looked at single characters, and we know that if we want to declare a variable to hold one character, we're going to use char, which stands for character. That's our data type, and then we're going to give the variable a name. So in this case, I've called it ch for character. Remember, all variable declarations are terminated with a semicolon. Now, if we want to represent a string, in C we do that as an array of characters. So here our data type is char, as it was over with a single character. I've called my variable str, which is pretty common when we're working with strings. You'll either see s or str. And then we need to tell it how many characters that string has to be able to hold. Now it's important to remember when you're talking about this size that it has to have enough space to hold all the characters you want to use plus one more. And that extra one is a string terminator. And it's very important, if we don't have that string terminator at the end of a string and we try to print it, it's going to continue to print whatever characters it finds in those memory locations until it finds that terminator. So if we assign a string, that terminator would get written automatically. But if we decide to access this array as a character array instead of as a string, then it's our responsibility to put that string terminator, which is a \0 inside single quotes. We need to put that as the very last character so that it knows where the string ends. C provides us with a couple of libraries that are full of functions that we can use to work with characters and strings. So let's look at some of the character functions first. The first set that we have here are all to do with character input. So we can use getChar, and that's going to return one character to us. We can use getch, which does a similar thing, and we can use getch with echo. So the E here stands for echo. So the difference between getch and getch-e are that getch-e is going to echo the character the user types in onto the screen as they type it. Getch isn't. So getch is particularly useful if we want to do a password, for example. All three of these will return a single character and need to be assigned to a variable that we've declared. Scanf is pretty common to us now. We're going to read in, we're going to format and specify that we're going to read a character, and we're going to say the address of the variable we've defined. The last three we have down here are for outputting characters. So the first one is putC. The character it's going to put, and it's going to put it to the default output, which is the screen. So it's going to print whatever ch is. Similarly, putChar is going to do that. And finally, printf is going to, because we've told it to print a character, print out whatever that character is. Now if we look at strings, we have similar things. We have a couple of input functions. The first is getString, so pretty straightforward. The string that the user enters is going to be stored in a variable that we've defined as str. Now it's very important that str have enough space to hold all the characters that the user types in. This will automatically put that string terminator at the end, so we don't need to worry about that. Same thing with scanf. This will allow us to enter a string that the user types in because we've specified with an S here that we're going to input a string. The important thing to remember about scanf is that it only reads up to the first space or carriage return, whereas getString will read spaces as part of a string. So if we wanted to read in our whole name, we'd want to use getString. If we only wanted to process the first word a user types in, we'd use scanf. The last two here are for string output. So putString is the partner to getString, and it's going to take whatever is in str up to that terminator and print it out to the default output device or the screen. Printf is going to, because we've told it in our format specifier to print a string, it's going to print the contents of str as well. Now we're going to look at some of the most commonly used character functions, and we have two different types. We have ones that convert things, and we have another set that check characters. So let's look at the conversion ones first. And the two conversion ones we have are right up here on the right-hand side. The first is to lower, and what that allows us to do is to convert any uppercase letter to a lowercase letter. And the nice thing about that is it doesn't matter whether this character is uppercase or lowercase, we'll always end up with a lowercase one. Similarly here, it doesn't matter whether we enter a lowercase a or an uppercase a. After this function has been executed to upper, it's always going to be a capital letter. These are particularly useful to us if we want to do a comparison for the user, for example. So maybe they're entering a yes or a no answer. So what we can do is say, let's use to upper. So we want to take that user input, which is ch, and this, regardless of whether we type a y or a capital Y, is going to convert it to an uppercase letter. So I'm always going to have an uppercase. Then I can say, is it equal to the uppercase letter Y? So here, I do whatever the user enters, it's converted to an uppercase letter, and then I compare it to a capital Y. So I no longer have to say if it's equal to a lowercase y or it's equal to an uppercase Y, do such and such. I can do that all in one check now. Now let's take a look at our checking functions. And we have a whole bunch of them. So the first two have to do with checking for uppercase or lowercase letters. So I can say, is an input, and maybe it's one of these things. If I check this second one, for example, is it lowercase? The answer is going to be no, so it's going to return a false. So each of these conversions are going to return either a true or a false for us. So if the character was 0 and I checked is upper, it would return false because it's not an uppercase letter. If I had that same 0 and I said is it a digit, then it's going to return true because is digit is going to return a true for anything that's a digit 0 through 9. We have over here, is it a hexadecimal digit? So the X in here means hexadecimal. So it's going to return a true for 8 or E or 0 or B, anything like that. If it's a G, it's going to return false. And those will work with is alpha, and is X digit will work with both uppercase and lowercase letters. Is alpha is checking for any letter in the alphabet, so A through Z, either uppercase or lowercase. Is space is looking specifically for the character space that you'd press with your space bar on the keyboard. Punctuation is looking for a comma, an exclamation mark, a question mark, a period, any of the common punctuation marks. Is alphanumeric looks at anything that is 0 through 9 or A through Z. And control is looking for our typical control characters, so control C is one we use a lot. Now let's take a look at some of the most commonly used string functions. Up at the top here, I've defined 4 strings. So we can see our first string str is defined to be size. Right now this string is empty. I've reserved size bytes, but I haven't put anything in that string yet. Now for the other three strings, string 1, string 2, and string 3, I have actually assigned values to those strings. So string 1 has all the characters first string 2 has ... and more text, and string 3 has 1, 2, 3. And those are the characters 1, 2, 3, not the value 123. So let's look at some of these functions. The first is string length, and what it does is counts how many characters are in the string. So here, the string that we're using is string 1, so we come up to string 1 and we say there's 1, 2, 3, 4, 5 letters in first. 1 for the space makes 6, 7, 8, 9, 10, 11, 12 characters. So string length is going to return 12 and assign that to X. So it does not count the string terminator. It counts all the characters except that terminator. The next one is string copy. So unlike a variable where we can say X is equal to 2, we cannot say str is equal to ABC. Unfortunately, although it would be nice to do, it doesn't work. So we have to use the string copy function. Now it's important when we have two variables in a string related function. The first is always going to be the destination. The second is always going to be the source. And what that means is we're going to be taking information from the source and moving it to, or the final answer will be in destination. So here we're going to copy what's in string 1 into string str. So when this second instruction is going to be complete, str, which is my destination string, is going to have first string in it. So at the end, str will have first string. Now let's look at the third one. This one is string concatenate. So CAT stands for concatenate, and concatenate means tack on the end. So our destination is str. String 2 means we're going to tack string 2, which says ... and more text, onto the end of str. Well, str right now has first string in it because we just copied string 1 into str. Now we're going to tack what is in string 2 onto the end. So at the end of this one, our string is going to now have first string, ... and more text. So it's getting a bit long. So if we're going to do operations like this, and then we have all these characters in here now, so we had 12 before, plus another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, at least 17. We need to make sure that this size that we've defined for string is big enough to hold all of that information. Now let's look at the last one down here. Oh, actually we've got two more. We've got string compare. This one is going to compare the first variable, first parameter, to the second parameter, so str to str2, str, str2. str currently has this big long string of text, str, and str2 has and more text. So what it's going to happen, it's going to go character by character. So it's going to compare the space to the F, and it's going to stop right away because they're not equal. Now the nice thing about this is it returns three things, or it's going to return one thing. It's going to return an integer. If they're equal, it's going to return a 0, saying there are no differences. If the F, which is the first character of str, is less than the space, which is the first character of str2, it's going to return a value less than 0. So it's going to go character by character until it finds a difference, and then it's going to compare those two particular characters and tell you whether it's less than or it's greater than. So we get a lot of information from string compare. Usually we just use it to check for 0 or not 0, but it is possible to know which string alphabetically comes first. The final one we're going to look at is A to I. The A stands for ASCII, 2, integer. So here we can take a string, as we have in string number 3 up here, which has digits in it. So we can take str3, which has the characters 1, 2, 3, and using this function, ASCII to integer, convert them to 123. So at the end, x is going to be equal to 123. So we've looked at the common input and output functions for both characters and strings. We've looked at some of the conversion and assignment functions and checking functions for characters, and now we've looked at some of the more common functions for strings.